We're going to look at injection methods, different ways to inject chemicals into the water supply as we pump it out into the field. The first one is gravity mixing. Now all of these are in your text. I'm sure you all read ahead and checked it all out very carefully. Gravity mixing is basically an illegal operation. It's where you dump the chemical in on the suction side of the pump and let it suck the chemical into the system. Well, it's like almost an instant guaranteed way to contaminate your water supply. Now, people will do that on systems where they have a pond and they've diverted water into a pond from a surface supply, and then they'll have a pump down at the end of the pond, and as they're pumping out of their pond, they will simply trickle the chemical into the water right at the suction of the pipe. Or they will plumb it in directly into the suction line if it's a liquid chemical, and they just turn on a valve and allow the suction to suck the liquid out of the barrel that the chemical is stored in right into the water as it's being sucked through the pump. It's very effective, but what happens if the pump shuts off? The liquid just continues to flow and drains right down into the pond or the sump, and all your chemical now is contaminating your water. So it's obviously an illegal way to do it, but it's a real cheap way to do it and very unsophisticated, and unfortunately it is done in places. But don't do it. You know, that's not the right way to do it. The other would be suction side injection. And here again, we have the problem of trying to force the liquid into the suction side of the pump. Well, it's real nice to do it that way because on the suction side, there's no pressure. And in fact, you're pulling a partial vacuum on the suction side of most pumps. And so it'll actually aid the liquid coming into the system, but it's on the wrong side of the pump, and there's no way to protect the water supply. Again, if it shuts off, the pump shuts off, you have leakage back into the water supply. So those are another method that is very ecologically unsound procedure. The next is a venturi. Now we're on the pressure side of the pump. So we've gone past our protection devices, whether it's a check valve, a double check valve, air relief system of some variety, pressure or atmospheric air relief. At least now we have the protection that we're after, preferably a double check. And now it's on a pressurized side, and I have a really small venturi. This would be used on a 1/2 inch or 3/4 inch line, something you could use to inject into a home residential system, for example. And it works off the concept of a venturi by the name, venturi. And what a venturi is a big pipe that necks down very rapidly to a very small opening and then expands right back up again. So if we look at a venturi, and what we do is we put a little hole right here, and now we have liquid flowing in a direction. Now what happens hydraulically is this. Real low velocity over here on the left-hand side of the venturi as it enters the venturi. As we neck the piping down, we have the same flow rate at this point as we do at this point. So what has to happen to the water? It has to get going way faster, doesn't it? So we've increased the velocity radically from the point of the full pipe size into the throat of the venturi. Now whenever we increase the velocity, it drops the pressure. So all of a sudden the pressure over here, we'll just call this point A. Right here, we'll call that point A. And we'll just call this point right here point B. So the pressure at A is going to be quite a bit greater than the pressure at B. What we've done is we've converted pressure to velocity head. And actually what has happened is now we have gone from pressure head to kinetic energy. We've converted, by increasing the velocity, we've converted a bunch of that pressure into kinetic energy, speed of water, the high velocity of the water. So the pressure drops to conversely affect it.